Traditional procurement decisions often prioritize the lowest purchase price while ignoring long-term operational costs. Total cost of ownership, or TCO, changes this approach by evaluating the full lifecycle cost of a product or asset, including operation, maintenance, disposal, and even carbon-related costs where carbon pricing applies. As organizations face growing pressure to reduce Scope 3 emissions, TCO helps procurement teams align sourcing decisions with both financial and sustainability objectives. In practice, TCO means evaluating costs across the full operational life of an asset. Procurement teams define a time horizon, often between 5 and 15 years, and estimate the major lifecycle cost categories. These include acquisition costs, operating expenses such as energy consumption, maintenance and repair costs, and end-of-life expenses like recycling, disposal, environmental remediation, or carbon offset costs. TCO matters because low purchase prices often hide significant downstream liabilities. Energy-intensive equipment becomes more expensive as carbon pricing mechanisms tighten, and low-quality products create higher maintenance, replacement, and waste disposal costs over time. TCO reveals that more durable, energy-efficient, and recyclable products often perform better financially while also supporting sustainability goals. Despite its advantages, total cost of ownership is still underused in many organizations. Procurement KPIs are often tied only to short-term unit cost savings. Operational data is difficult to access, and many ERP systems do not support lifecycle cost modeling. In addition, most organizations still fail to internalize carbon costs when comparing suppliers and sourcing options. The first step in applying TCO is defining which lifecycle cost components are relevant for the specific product or asset category. For example, fleet vehicles require fuel and maintenance analysis. Manufacturing equipment depends heavily on energy consumption and downtime, and software platforms involve integration and switching costs. TCO frameworks should be scoped according to materiality rather than using the same template for every procurement category. Data collection is often the most difficult part of TCO implementation. Procurement teams must combine supplier specifications, internal operational records, and third-party benchmarks to create reliable cost models. Supplier energy efficiency ratings, maintenance history, recyclability data, and carbon intensity information are increasingly required to support Scope 3, reporting and supplier assessments. Once lifecycle costs are calculated, TCO must be formally integrated into sourcing decisions. Supplier scorecards and RFP evaluations should assign explicit weighting to lifecycle value alongside price, quality, and delivery performance. When suppliers know that energy efficiency, durability, and carbon performance influence supplier selection, they gain a strong commercial incentive to improve their environmental performance. A common example of TCO appears in industrial equipment procurement. One machine may have a lower upfront purchase price but consume significantly more electricity and require more frequent servicing. Another machine may cost more initially but operate more efficiently, last longer, and generate lower emissions. In many cases, the higher upfront investment becomes the lower-cost option within just a few years. Mature organizations apply TCO systematically across defined spend categories, such as fleet, capital equipment, and high-value service contracts. Procurement works closely with engineering, operations, and finance to validate assumptions and integrate lifecycle costs directly into sourcing decisions. Effective organizations also track actual lifecycle performance over time, creating a continuous learning system that improves future procurement decisions while reducing both cost exposure and carbon emissions.